Hi there. Some of you probably know me from the Tennis Files book series, or from my novella, The Test. My next novel is called A History of What Comes Next. Tor.com calls it a fast-moving, darkly satirical look at 1940s rocketry, with an exploration of the amorality of progress and the nature of violence. It's available for pre-order right now and will be released on February 2nd. In the meantime, let's talk rockets. My name is Sylvain Neuvel, and this is SpaceRace 101. Where's space? You might think it begins where the atmosphere ends, but the Earth's atmosphere doesn't so much end as it just peters out. The sun squishes the atmosphere a bit, but on the night side you'll find traces of hydrogen all the way to the distance of the moon. What we call space begins way closer. In the 50s, a fellow by the name of Theodore von Karman calculated how high a plane could go before the air became too thin for it to get any lift. And he came up with 83.6 kilometers. That's 51.9 miles. 83.6 isn't the catchiest number, so folks rounded up to an even hundred and called that the Karman Line. The World Air Sports Federation, or FIA, a record-keeping organization that basically has no power over anything, defined the boundary to space at 100 kilometers, and for some reason everyone just went with it. Except, of course, people who actually go to space. NASA will give you your astronaut wings if you fly just 50 miles or 80 kilometers in that direction. If the Earth were a basketball, 50 miles would be the size of a nickel, sideways. There. Anything above the nickel is space. Seems easy, doesn't it? And yet, the highest we've ever been in a jet plane is about 38 kilometers. That was with a Russian MiG. Propeller planes and hot air balloons only reached about 20 kilometers. Other gases will get you a bit farther. You might remember from a few years ago. The senior VP at Google jumped out from a helium balloon at 41 kilometers in altitude. We're going to need something else to get to space, and as it turns out, we've been playing with the right idea for quite some time. Black powder originated in China during the 9th or 10th century. A couple centuries later, the Chinese were shooting fire arrows at their enemies. There were short bamboo tubes filled with black powder that were able to propel themselves. No idea how much power these things had, but they were probably very good at setting things on fire. We'd have to wait until the 1800s to get our first rocket science. But the real fun begins at the beginning of the 20th century. By then we have much better science from a bunch of people in a bunch of places. Like Konstantin Tsiolkovsky in Russia, Hermann Oberth in Germany, Robert Renaud-Peltry in France, and an American scientist named Robert Goddard. That's him right there. Tiny, poorly painted Goddard. He was bigger than that in real life, though. The strange contraption sitting next to him is called Nell, and Nell is the first ever liquid-fueled rocket ever built. On March 16, 1926, Nell flew for 2.5 seconds and reached an altitude of 41 feet. I know he could have thrown the rocket higher than that, but that short flight arguably marked the beginning of the space age. In our next episode, we'll talk about how rockets work. You can pre-order A History of What Comes Next right now from your favorite local bookstore. In fact, it would be pretty cool if you did. So thank you all for watching. You're still here. Alright then, let me tell you something really cool about Theodore von Karman. Back in the 30s, he was a teacher at Caltech, and he had a bunch of super bright students who liked to build rockets. Now, one of the things they did, besides accidentally blowing stuff up, was to attach small rockets to planes to help them take off faster. They called those jet-assisted takeoff rockets or something. Anyway, the army liked it enough to give him a bunch of money, and they started what they would call the Jet Propulsion Laboratory, or JPL. Ta-da! Thank you again. Have a good time.